Hello students, welcome to this session. I have just solved this JEE Main Test 68 and now we are with the analysis of this paper. So paper was not a tough one. I have regarded what you can see 3, 6, 8 questions as easy, one as tough, and that is also not that very tough. And then we have 3, 6 remaining, we have 16 questions. So just remember, it's a nice paper. There are some calculations, but there are no such question which will be, let's say, you haven't done in your practice sheets or the institute materials. So it's a not that uncomfortable paper, so this prepared students will feel easier in this paper. So for a student above average expecting something good in physics, it should be 60 plus, and for very good students again it should be 85 plus in this particular sort of paper. So let's see what is. So let's begin. The first question: the kinetic energy of an electron having de Broglie wavelength lambda is. So it's a straightforward one. You know lambda is h by p, which is h by mv, which you write as h upon root 2 mk. Now, so kinetic energy would be h square upon 2m lambda square. So go for option B. So that's a quite irregular one for you. Next, two particles 2 kg 3 kg masses are projected horizontally in opposite direction from the top of a tower of height 39.2 meters with speeds 5 and 10. The horizontal range of the cm of the two particles, because both are projected from same height and one is projected here, one is projected here. So what we can say, the y velocity, y component for both is 0. Uy is 0 for both have to travel the same height and both have same acceleration, so time is same. So both will land at the same time, so it would be easy for us to calculate. First of all, what would be the time? Time you know is equal to root 2 h by g, and h is given as 39.2 and this is 9.8, so this is 4 2 into 4 8, that is root 8 second you can take out. Now what would be this time? In this time, the first one travels distance r1, let's say it would be forward, r2 would be backward. So let's say r1 would be what we have 5, so we write it as u into root 2 h by g, u into t, basically what you write. So u is what we had 5 into root 8, and similarly r2 would be again u into root 2 h by g, this is u1, this is u2, that would be 10 into root 8. So if I take the cm's position, I am taking, this is one, there is the 2 1 and this one is the 3 1. So I take this direction as positive x because 3 would be more and its speed are more. So what we'll have, the xcm would be what we can write 3 into 10 root 8 plus 2 into minus 5 root 8 divided by 3 plus 2, that is 5. So that is 30 minus 10, that is 20 root 8 by 5, that is 4 root 8. So 4 root 8 you can write as 8 root 2 and it is in the direction of the 3 kg. So I'll go for option B. So it's just a regular one asked very smartly, you should go for it. Next, in a closed circuit, the current in an instant of time is this. Okay, the number of electrons flowing in 50 seconds through the cross section. So first of all, you have to calculate what is the charge crossing. You know, charge crossing in an interval is equal to IDT. So IDT is 4 minus, you should write it as 80 by 100 or 0.080, whatever you wish, you are comfortable with, and it is from 0 to 50 seconds. So what we'll have now, this is 40 minus, this will become 40 square by 100 from 0 to 50. So put 50, 4 into 50 minus 4 into 50 into 50 by 100, 0 will be 0, so no point in writing it. This would be 2, this would be 2, this is 200 minus 100, that is 100 coulombs. So for 100 coulomb charge, number of electrons, let's say let be capital N into E, so that capital N is charge of single electron is E, so N would be 100 upon 1.6 into 10 to the power minus 19. So if I do this, it would be 10 to the power 20 into 10 upon 1.6, so it would be 6 point something into 10 to the power 20. So this would be option B I'll be going for. Next, you have 5 identical resistors of resistance 1500 ohm connected to a 300 volt battery as in the figure. Okay, the reading of the ideal ammeter is, so we can say its reading would be equal to the current flowing in these three, not these two, because these two will go here, they won't pass through it, and because all are in parallel, current through each, our current through each is going to be 300 upon 1500, that is 1 by 5 ampere. So 3 resistors current will pass, that is 3 by 5 ampere. So I'll go for B option. The current read by the ammeter is 3 by 5 amperes. Next one, the output of a step down transformer is measured to be 48 when connected to a 12 watt bulb. The value of peak current is, so it is 48 is the output is 48 when connected to a 12 volt. 48 means you can directly say it would be VRMS, because what we measure is generally the VRMS, and it is connected to a 12 watt bulb. So what we can say, power would be equal to VRMS. IRMS I am taking because I am assuming it to be a pure resistor, cos phi is 1. So IRMS for me is 1 by 4 ampere. So I max would be, yeah, I peak would be root 2 times 1 by 4. Root 2 times IRMS, that comes out as 1 upon 2 root 2 ampere. So for me the option would be option C. I'll go for. Next, always remember that what we measure in AC is generally the RMS. Electric field at 10x I cap Newton per coulomb exists in space where x is in meter. Consider the potential at 10, 20, to be 0. The potential at the origin is, because it is along x. Now since field is along origin, along x-axis, sorry, we need to consider only the displacement in x. This point x coordinate is 10 meter where potential is 0. You have to find at origin where potential x is 0. What is the potential here? So what would be the change here? So the magnitude of the change will be simply e dx, that is 10x dx, let's say from 0 to 10. And because field here is going to be positive, x is positive, so I can directly say along going the field potential will decrease, and this is 0, so definitely it will be a positive value. So I will only be considered about the magnitude. I know it is positive, all options are also positive. So that v would be 10x dx. 10x dx, that is 5x square, from 0 to 10, that is 5 into 10 whole square. So it comes out as 500 volt. So it's an easy, not easy, but a very good question. You can say very smartly asked question. Next. A non-conducting ring have a uniform linear charge density lambda, rotates with angular speed omega about an axis through the center and perpendicular to its plane, the magnetic field at center. So it would become a rotating ring. So first of all, what would be the current because of that rotation? You know that is equal to Q into F. Q you can write as lambda into 2 pi r, total current charge, and F you can write as omega by 2 pi. And now the field at the center, you know, due to a charged ring, that formula you all remember, that is mu naught I by 2r. So putting that formula, what we will have, this would be mu naught I is, this 2 pi goes, so mu naught lambda omega r upon 2r. So this r and r goes, this is mu naught lambda omega by 2. I can see this as option B. So this is the 7th, option B would be right. Next, we have an elevator of mass m connected to a rope which pulls the elevator with maximum acceleration a. If the maximum bearable tension is T, then for a safe journey the minimum diameter of the rope is OK. So the minimum diameter of the rope is, your maximum bearable tension is like this. So first of all, I know the T max that will be generated during the journey, that would be equal to m g plus a, and this should be equal to T. That is what I can say, that should be less than equals to T. Here what I feel the question is talking about the stress, not the tension. This should be, this T is not the tension, this is the stress. Okay, so that would be T into the force would be stress, what you know, is equal to force upon area. So that area, so that force, that is actual tension, would be that stress into area. So I should write it T into pi r square. So from here what I get here, r square should be greater than equal to mg plus a divided by pi t. That is what I am getting. So r should be greater than equal to mg plus a upon pi t under root. So it should be maximum bearable stress, because that is what the material's property is, and that is what the general questions about it is. So what we have now, going by the options, if I check out, it would be, this is radius. Okay, question has asked for minimum diameter. Okay, so for the diameter it should be greater than 2r, so diameter should be greater than 2. If I take it, and inside it would be 4mg plus a into pi t. So be careful, otherwise I would have ticked for C, but the option is B because it has asked for diameter, not the radius. I put it in the terms of radius first. Next, you have atomic masses of hydrogen, deuteron and helium. Nucleus is given. Taking velocity of light in vacuum to be this, calculate the amount of energy liberated with 2 moles of 2H1 undergoes a fission to form 1 mole of 4H2. Okay, so what we have, 2H1 plus 2H1 giving 4H2. So first of all, in a single reaction, what we have, the mass it is utilizing is double of that, that is 4.0282. Okay, and what we form is 4.0026. Now mass defect in a single reaction I can make out, if I solve it, is this term, this is 12 minus 6, this would be 7 minus 2, 5, this is 2.0256 U. Okay, so energy of a single reaction would be 0.0256. So for approximation, let's say take it to be 26 and take it to be 930 MeV, and do that simplification because options are far away. So if I do this, this would become what I can directly write 2.6 into 9.3. that would be better for me. So it is 26 into 90, 26 threes. If I do, it is 78. 26 nines are 260, 240, 236 and 7, 243. So it is would be 24.38, and let's convert it into 1.6 into 10 to the power minus 13 joule. We'll calculate it further. Now this reaction requires 2 atoms and we have 2 moles of 2H1. 2 moles means total reactions would be Na number of reactions will take place. So therefore total energy would be Na means 6 into 10 to the power 23 by multiplied by this factor, which is 24.38 into 1.6 into 10 to the power minus 13. So this is 23 and 13, that is 10 to the power 10. Now what we have, 6 into 1.6 is 9.6 into 24.38, so it would be less than 240. So it would be 200 something into 10 to the power 10. So I'll go for 2.3 into 10 to the power 12 joules. So slightly calculative, but such questions are always calculative when you are given this fusion masses. Next one. The position and velocity of a particle executing SHM at t equal to 0 was 3 cm and 8 cm per second. If the angular frequency of the particle is this, then the amplitude is okay. At t equal to 0, position is given and velocity is given and frequency is given. You know v at any position is omega under root a square minus x square. So v is 8 cm per second, omega is 2 radian per second, so keep it in centimeters only. A square minus x square, that is 9. So what you have, a square minus 9 is equal to 8 by 2, that is 4 square, that is 16. So a square is 25, so it becomes easy, a equals to 5 centimeter. So you can go for this. This is the regular question. Amplitude would be 5 centimeter here. Silver has a work function of 4.7 eV. When UV light of 100 nanometer means energy of the light would be 1240 upon 100, 12.4. So it would be able to take out electron. A potential of 7.7 eV is required to stop the photoelectrons from reaching the collector plate. 4.7 plus 7.7, yes, that is 12.4. The potential required to stop the photoelectrons when the light of wavelength 200 nanometer is incident. In that case, E dash would be half of that because lambda is doubled, that would be 6.2. So Vs required or would be simply 6.2 minus 4.7 here. You can do that Kmax and everything. So 12.75, this would be 1.5 volt. So again, a very simple question from this photoelectric effect theory. Now, to infinite long wires carry charge density lambda and minus lambda. Okay, the potential difference between points A and B at a distance B from the second wire is okay. Now what would be that? So first of all, for that we need to write the electric field at a general point like this. Let this distance be x, this would be d minus x. So the field due to this one would be there and due to this one would be there. Both field are towards right. So the field I can write it as, due to the first one is 2k lambda by x, second one is 2k lambda upon d minus x. So what we have, it is 2k lambda, take it as common, 1 plus x, 1 by x plus 1 upon d minus x. Do the calculation, 2k lambda d upon x into d minus x, that is what you have got. Okay, so field is led towards this. So what we have, the potential difference, if I have to calculate, I can directly say A is higher and B is lower. So just calculate the value of E dx at delta V. I have to find, it would be, let's say, E dx magnitude. So E would be 2k lambda d x upon d minus x dx, and the limit of x will go from A to what I can write, d minus b, that is what I can write. So now this is if you do integration, you have to convert it into this form, that would be the better. So I take 2k lambda common and integration I can write 1 plus x plus 1 upon d minus x dx from a to d minus b. So the first term will give me ln of d minus b by d, and the second one will give me 2k lambda, and this would be ln of d minus x, that is d minus b. So d minus b will give me b, and this would be give me this would be d minus a, and because of this negative sign I'll put it here minus, because that minus x was there, so it would be minus here. So if I do this, because in log a minus log b means log of a by b, so 2k lambda, it would be ln of d minus b by d into this will become d minus a by b. So this is how we are getting it. So what is left now, as per the options all look like same, 2k lambda. Okay, so k is 1 upon 4 pi epsilon naught, so it would be lambda upon 2 pi epsilon naught, not the 4 pi epsilon naught, and I'll go for option A. This is what I'm getting. So good question this one. Next, a prism is made up of a material of index refractive root 2. Prism angle is A. Minimum angle of deviation is equal to the angle of prism. This is a very common question. What you so know the formula N is sine of del min plus A upon 2 upon sine of A by 2. Now what we have here, N is root 2, del min is also equal to A, so that is sine A I can write it as 2 sine A by 2 cos A by 2 divided by sine of A by 2. So this goes, so what we have, cos of A by 2 is 1 by root 2, that means A by 2 is pi by 4, so A comes out as pi by 2, that is pi by 2 you know is equals to 90 degrees, so go for option D here. Now the next, a ballet dancer is rotating about its vertical axis on smooth floor with a period 0.5 second. Okay, the dancer holds himself close to his axis of rotation, due to which radius of gyration decreases by 20%. That means moment of inertia will decrease, so the omega will increase, so time period will decrease for sure. Now what would be, we know I into omega will remain constant and I is proportional to k square. So what I can say, k1 square omega 1 would be equal to k2 square omega 2, and omega is inverse 2 times, so I can write k1 square by t1 is equal to k2 square by t2. So t2 is going to be t1 into k2 by k1 whole square. So it is 20% reduced, so k2 is 0.8 k1 upon k1 whole square, that is 0.64 times the original period. So 0.64 into 0.5, that is 0.32 seconds that I can go for. So this is a regular angular momentum conservation question. A change of 8 milliampere in the emitter brings a change of 7.9 in the collector. So I can directly go for what is the alpha. Alpha is delta IC by delta E in that case. So delta IC is 7.9, this is 8. So 7.9 by 8, that is 79 by 80, or you can write it, it would be 0.980. What you do, 89, that is 720, you are left with 700, so it is 0.98. and what we have, it's a 64, 600 we are left with, 600 we are left with, that means would be 0.987, that is 0.99 for the closest one. So we have these two options. Now beta, if we write, we know beta is equal to delta IC by delta IB. So IC changes 7.9, and from the data I can see the change in collector base current would be 0.1, so it is 0.1, so it is going to be 79 here. So I'll go for option D, that is the most appropriate one here. Okay, next one. After 15-16, a solid floats in a liquid with some fraction of its volume submerged. If for two different temperatures T1 and T2 the fraction of the volume of the solid submerged in the liquid are F1 and F2 respectively, then the coefficient of volume expansion of the liquid is, okay, and assume solid does not expand. So solid floats in a liquid with some fraction submerged. If two temperature, the fraction is like this. So first of all, we know the fraction of volume submerged to the total volume is always equals to rho of body upon rho of fluid, for sure, that you know. So what we have at the first temperature, what we have, this fraction F1 is equal to, because rho of body remains same, rho of fluid, let's say, let's call it rho at T1, and F2 would be equal to rho B upon density. So what we have now, F1 upon F2 is density at T2 upon density at T1. Okay, so this is what we have got. So now the ratio of the density is at two temperature. I can say rho 2 upon rho 1 is equal to V1 upon V2, and let's say it can be written as, and the ratio would be 1 plus gamma T1 upon 1 plus gamma T2, taking V0 to be the reference one. So it would be 1 plus gamma T1 upon 1 plus gamma T2. That is what you can write it here like that. So F1 by F2 is coming out as this 1 plus gamma T2 upon gamma T1, that is what we can write. So now multiply it, what will have, F1 plus F1 gamma T2 is equal to F2 plus F2 gamma T1. So now what we have now, this gamma will now be F1 minus F2, and it would be F1 T2, sorry, F2 T1 minus F1 T2. So going by this would be option A, that would be the answer here. So this is how they have given this answer. Generally, if you have taken this rho 1 and rho 2 as rho 1 into 1 plus gamma T2 minus T1, no option was coming. I tried that, but an answer was not coming. Answer is coming only by this way. So we have to go by what the choices are given. Next one. Focal length of a mirror is this, you know all. And the maximum relative error in F is. So what is the maximum relative error in F? So maximum relative error, normally what we do in this particular type of question is, if we have to, first of all we have to write it in the form that f would be what I can say uv upon u plus v. So it depends on this quantity, this quantity, this quantity. So going by the logics, this delta f by f would be, first of all it would be delta of uv upon what I can say delta of uv upon what I can say, okay, not delta of uv, it should be better because they are in multiplication, delta u by u plus delta v by v, and because it is in division, error will remain same, delta of u plus v upon u plus v. So if I do this, I can separate it out because of the sum of the thing, a plus b, error would be delta a plus delta b. So going by that, I think option D is the most appropriate one. Generally what we do for the smaller changes, we typically write delta f by f square is delta u by u square plus delta v by v square, which is the no option like that is given. So you have to go by this thing only. Next, two Polaroids placed with their Polaroid axis 30 degree to each other. Okay, plane polarized light passes through A, and after passing through it, it's become I naught. So after that it is I naught, and because this angle is 30, this will become I naught. Cos square 30, cos square 30 you all know is 3 by 4, so 3 by 4 I naught, go 4.75 I naught. Next one, standing waves are produced by the superposition of these two waves. Okay, the amplitude of the particle at 0.5 meter will be, so first of all what would be the wave? I should write y1 plus y2. So 0.05 into 2, I'll get 2a, and because it is sin a minus b and sin a plus sin b, so what we have, sin a plus sin b is 2 sin of a plus b by 2, that is sin of 3 pi t, and it would be cos of 2x. That is what we are getting. So the amplitude term would be 1 cos 2x at any point. So at 0.5 it would be 1 plus cos of 1, and 1 radian is 57.3, which is given as 0.54. So that is equal to not it should be 1 into cos 1, I'm writing it wrong. So amplitude would be 1 into cos of 1 radian, and cos of 1 radian, that is 57.3 degrees, given as 0.54. So it is going to be 1 into 0.54, that is 0.54, what I can say, okay, 0.05 into 2, it is 0.1, I am doing mistake. So it is 0.054 meters, or I can write it as 5.4 centimeters. So go for option B. So it's a good one. You need to remember it is in radian to conversion to degree they have given as a hint, so it's not that tough now. Two men in the weight ratio 4:3 run up the staircase in time 12:11. The ratio of the power is basically mgh by t. So power would be the ratio of m by t, what we can say. So p1 by p2 is m1 by m2 into t2 by t1. So m1 by m2 is 4 by 3, and t2 by t1 is 11 by 12. This is 3, this is 11:9. So go for option D. Not a tough one for you, you could do that. Next one. So okay, so we are done with the SOTs. Now the numerical ones. 5 equal point charges, 10 nanocoulomb, 2, 4, 5, 10, 20 you have placed. Taking the value of permittivity of free space is okay, value is changed. Okay, and putting it is same thing, 1 upon 36 pi, so 1 upon 4 pi, it would be that again 9 into 10 to the power 9k is that. And potential at infinity to be 0, calculate the potential at x equal to 0. Okay, let me check. 2, 4, 5, 10, 20. So what would be the potential at origin? We say due to the first one it is k cube by 2, second one is k cube by 4, k cube by 5, k cube by 10, k cube by 20. Okay, so let me solve it. So first of all, what is the value of kq? Kq is 9 into 10 to the power 9 into 10 into 10 to the power minus 9, so it comes out as 90. So it is 90 by 2, 90 by 4, 90 by 5, 90 by 10, 90 by 20. So you are smart enough. This is 45, this is what you can say 22.5, this is 18, this is 9, this is 4.5. So this becomes 22, 26, 27, 27 and 9, 36, 36 and 18, 54, 54 and 45, it is 99. That snake and ladder, 99. So this is 99 is going to be the answer. Next, it's a smart question. Next, two stations are 110 km apart on a straight line. One train starts from A at 7, travels towards B at 20 kmph. Another train from B starts at 8 am and travels towards 8 at a speed of 25. How many hours after the start the train which starts from A will meet at? So first of all, they have to travel relatively 110 kilometers. Now from 7 to 8 a.m. this balloon is moving, so 20 kilometers is reduced. So now left distance is 90 kilometers. So now they are 90 kilometers apart and moving towards each other. So I can say the relative speed would be added, that would be 45 kmph, and the distance they have to cover is 90 kilometers, so additional time would be 2 hours. So after 2 hours of the starting of B, that means they will start at 10, they will meet at 10 a.m. So start the train which starts from A, so it started from A to 7 to 10, it would be 3 hours. For B it would be 2 hours, for A it would be 3 hours of journey, after which it meets B. Next one. The rate of heat radiation from two patches of skin each of area A on a patient chest differ by 2%. Okay, if the patch at the lower temperature is 300 and emissivity of both is same, is assumed to be unity, then what is the approximate temperature of the other patch? Ignore all the higher order terms in approximation. Okay, so let me check. So the first one, let's say, would be some k times t to the power 4, I can directly write, and for the second terms it would be k times t plus change would be very small, delta t to the power 4, I can write. And because we have to neglect the higher terms, apply the binomial, it will become kt to the power 4 1 plus delta t by t to the power 4, and you can directly write 1 plus x to the power n as 1 plus nx, and the difference is 2%. So what I can say, E2 is 1.0 times E1. So k times t to the power 4 1 plus 4 delta t by t comes out as kt to the power 4 into 1.02. This goes. So 4 delta t by t you can make out as 0.02. So delta t is 0.02 into this 300 by 4. This is 75. 75 into 0.02. That comes out as, what I can say, 1.5 I can make out. So the temperature change is 1.5. So the temperature of that one would be 301.5. So it's a nice question, nicely designed one. Next. A Carnot engine whose low temperature reservoir is at 350 has an efficiency 50. It is desired to increase to 60% if the low one will remain constant. By how many Kelvin the temperature of the high one must be increased? So in the first case, efficiency was 1 by 2 is what 1 minus TC. TC was 350 by TH initially. So what we have, 350 by TH also comes out as 1 by 2. So TH was 700 Kelvin. Now to get efficiency 60, that is 3 by 5, it would be 1 minus 350 by TH dash. So 350 by TH dash becomes 2 by 5. So TH dash becomes 5 by 2 into 350. So this becomes 175 into 5. 5 5s are 5. 25, sorry, 35. 7 3 875. So 875, 700 to 875. So the change is 175 Kelvin here. Next one. The density of a liquid contained in a tank of area 0.5 meter square is 1200. Okay. The container is closed by a massless, frictionless, movable piston, and there is a hole of 1 centimeter square near the bottom of the container. 30 kg load is placed on the piston and the height of the liquid level is 75 above the bottom. What is the initial flow velocity? So it's a standard profile of Bernoulli. There's a hole here, there's a piston, there's the weight. So I just take let's say this point and apply the Bernoulli. So at this point pressure is P0 plus mg by A plus rho of water or rho of liquid into g into height. Here the atmospheric pressure, and it would be equal to half rho v square. Directly I can reply.